solving simultaneous equations using substitution method. How do we solve simultaneous equations using substitution method? Now we want to consider the two given equations here. So equation 1, we have 2x plus 3y is equal to 13. So this is equation 1. So we have 5x plus 2y is equal to 16. So this is equation 2. Now if you observe very well, in equation 1, the coefficient of x here is 2, coefficient of y here is 3, coefficient of x here is 5, coefficient of y here is 2. So none of the variables has a coefficient of 1. If there is any variable with a coefficient of 1, then we should make that variable the subject. So that would be the best and easiest approach using substitution method. But unfortunately, none of the variables here has a coefficient of 1. So we can make any of the variables the subject. Now from here so let us make x from equation 1 the subject. So from here we're going to have, from equation 1 we're going to have 2x is equal to 13 minus 3y. So we divide both sides by 2. Two will cancel 2. So therefore x is equal to 13 minus 3y over 2. So you can call this equation 3. Now from here we substitute x is equal to 13 minus 3y all over 2 into the second equation here. You don't substitute into the same equation from which you made the subject. No, you substitute into the second equation. So doing that, so we're going to have 5 into 13 minus 3y over 2 plus 2y is equal to what? 16. So from here we're going to have 65 minus 15y over 2 plus 2y is equal to 16. So here we have a fraction, this not a fraction. So in order to have uniformity, you can make this one fraction by saying over 1, this one 2 over 1, so that we have fractions everywhere. Now from here we try to match the left, what you have on the left hand side of the equation, we try to match this and this together. Doing that, we're going to have this. The denominator here is 2, the denominator here is 1. So LCM of 2 and 1 is 2. 2 into 2, 1. 1 times the numerator, we're going to have 1 into 65 minus 15, y, plus. Now here, 1 into 2, 2 times the numerator, we're going to have 2 into 2y is equal to 16 over 1. So from here now we're going to have 65 minus 15y plus 4y all over 2 then is equal to 16 over 1. So from here we're going to have 65 minus 15y plus 4y, so that is minus 11y over 2 is equal to 16 over 1. So from here we cross multiply. Try and put this in brackets, but this is a compound term in order to avoid the confusion. So cross multiplying, so we're going to have 1 into 65 minus 11y is equal to 16 times 2. So from here we're going to have 65 minus 11y is equal to 32. So from here we collect like terms. So doing that, we're going to have 65 minus 32 is equal to 11 y. Minus 32 here, move it to the left hand side, it becomes minus, this 32, move it to the left hand side, it becomes minus 32. Then this minus 11y, transfer it to the other side, becomes plus 11y. Whenever you move a term from one side of an equation to the other, the sign changes. So 65 minus 32, so that is 33 is equal to 11 y. So from here we divide both sides by 11. 11 will cancel 11. 11 here 1, 11 here 3. So therefore y is equal to 3. Now from here now we substitute y is equal to 3 back into equation 3 here. We substitute y here. So doing that, so we're going to have x is equal to 13 minus 3y over 2, and that will be equal to 13 minus 3, that is y, all over what? 2. So from here we are going to have 13 minus 9 all over 2. 13 minus 9, so that is 4. So we're going to have 4 all over 2 there. So therefore x is equal to what? 2. So therefore now x is equal to 2 and y is equal to 3. So this is how we solve simultaneous equations wherein the variables there, none of them would have coefficient of 1.